Hi guys, this video will cover density, cross-sections, and revolutions. We're going to actually talk about two different types of density, one probably that you've been familiar with since 7th or 8th grade in science, and then the other one probably you are not familiar with, called population density. For regular density, it's equal to mass over volume, and we can simplify this formula by saying D equals M over V. And you can kind of remember this as the DMV, Department of Motor Vehicles. Our steps here are to label what we know in the word problem as D, M, or V, and then substitute the values into the equation and solve for what you're missing. Sometimes you have to find the volume of the shape first though. So you can see this little example over here. It says what is the density if 0.196 grams occupies a volume of 100 milliliters. So we have D equals M over V, where they gave us the mass, 0.196 grams, and they gave us the volume. So we're plugging into the formula, just simply dividing, and we get the density. The other type of density that we have is population density, where population density is the same as population over area. We can again simplify this formula as PD equals P over A, where PD is population density, P is population, A is area. We have another quick little example over here. It tells us that the New York State Census in 2010 told us that the population of New York City is 8,175,133 people. The land area of the city is figured to be 302.65 square miles. So they give us the population and they give us the area. So we're asked what is the population density. That means simply put the population over the area and divide. It ends up telling us that we have 27,012 people per square mile. That's a lot of people. A square mile is 1 mile by 1 mile. That's not that much space if you really think about it. 27,000 people in that amount of space. You'll notice here that it does say that sometimes you'll have to find the area first before finding population density. The next thing that we're going to talk about is something called cross-sections. It's completely unrelated to density, so kind of get ready to change gears here. Cross-sections of 3D shapes are very, very thin slices of a 3D shape. You could think about, say, a brick of cheese. If I were to take my brick of cheese and slice a piece of that cheese from it, I could slice out the thinnest piece of cheese that I could possibly want, but we're talking about the shape of that slice of cheese. You can get shapes such as rectangles, squares, circles, triangles, ovals, or ellipses, trapezoids, etc. We can cut a cross-section in 3 different ways: horizontally, vertically, or angled. If we slice parallel to the base, then the cross-section is always the shape of the base. If we take a look at this pyramid to the right here, the base is a rectangle. If I take a slice parallel to that base, then the cross-section must also be a rectangle. Same thing happens here with this cone. The cone is a circle. If I slice parallel to the circle's base, or the cone's base, I get another circle. However, if I slice on a diagonal, I get an ellipse or an oval. If I slice a cylinder parallel to its base, then the base and the cylinder's cross-section are both circles. However, I could also slice it vertically. If I slice it vertically, then the cross-section ends up being a rectangle. There is a special case here when we talk about a sphere. If you think about a sphere and its cross-sections, you could take a cross-section horizontally, meaning you get a circle. You could take a cross-section vertically, meaning you get a circle, and you could also take a cross-section diagonally, and you still get a circle. No matter which way you slice it, you always get a circle. We have one more shape here down in the bottom right corner with this cone. If I slice through a cone vertically, the cross-section is a triangle. Now we're also going to kind of talk in the same type of relationship, but taking a 2D shape, revolving it continuously around an axis to create a 3D figure. So a perfect example of this is the revolving door that you might see at airports or fancy department stores. You start with a door that gets revolved around a single line or an axis continuously. As it revolves, it creates a 3D shape. And this one, because it's a rectangle, creates a cylinder. That door goes around and around and around, creating a cylinder. If you flip it over, we'll see some Common Core questions related to density, cross-sections, and revolutions. So for number 1 here, it says a wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. Our first step is to determine the density of the cube to the nearest thousandth. That's 3 decimal places. Afterwards, we'll state the type of wood based on the density table. So first step, D equals M over V. We don't know the density, so we'll keep the D. The M gets replaced by 137.8. And for volume, we actually have to calculate that. So we're going to calculate the volume of a cube. A cube has 3 congruent sides. Well, it has more than 3 congruent sides, but if you think about the dimensions, those dimensions, length, width, height, are all 6. They're all congruent. So we have length times width times height, each of which are getting replaced by 6. So 6 times 6 times 6 gives us a volume of 216. So that comes over here at the bottom of our fraction. We're going to type this in the calculator and get our decimal. Remember that we do need to round it to the nearest thousandth. So we get D equals 0.637963. Thousandth is 3 places, so we have D equals 0.63. The 7 does have to get bumped up to become an 8. So we have the density, and then it says state the type of wood based on the density table. So looking in the second column, the one that matches our density is ash. Okay, so we're moving on to question 2. Again, all of these questions have come from a Common Core exam once before, so it is fair game for them to ask something similar or related to all of these types of questions in the future. It says, during an experiment, the same type of bacteria is grown in 2 petri dishes. Petri dish A has a diameter of 51 millimeters and approximately 40,000 bacteria after 1 hour. The 40,000 bacteria is representing the population. Petri dish B has a diameter of 75 millimeters and approximately 72,000 bacteria. Again, that bacteria amount is representing population. So then it tells us the diameters are 51 and 72. When we think about any calculations that we've done thus far, whether it's area or volume, we need the radius. So to calculate the radius, remember that we take the diameter and divide by 2. So R equals 51 over 2. So the radius is 25.5. Over here, R equals 75 divided by 2. So the radius is 37.5. Now our goal here is to determine and state which petri dish has the greater population density. Remember, our population density formula is PD equals population, over area. They tell us the populations, that's great, except they don't tell us the areas, so that's not so great. We're going to split our paper up into kind of 2 sections with dish A and dish B. So we're going to find the area of dish A. We'll also find the area of dish B. That's just a little fancy A that I'm drawing to represent area. You don't have to draw a fancy A. I don't care. It doesn't matter to me. As long as you find the area, then we're good to go. So area on your reference sheet of a circle, these are petri dishes in the shape of circles, is pi r squared for both of them. So we're going to plug in our radius that we found for the first one, and we're going to type it into our calculator to get a number. Pi times 25.5 squared. You're not going to round it all. They didn't tell you to round, so we're going to leave it just the way that it is. 2042.82. Now to calculate the population density, we take our population, 40,000, and divide it by the area, 2042.82. Again, no rounding here. And we get PD equals 19.5808. So we have our population density for dish A. Now we have to go through a similar process for dish B. I'm going to do this independently, silently on the video, so if you need to, check in with me. Otherwise, move forward independently. If you need more time, just pause the video. Otherwise, we're going to answer the final question where it says determine and state which petri dish has the greater population density. Dish A came out to be 19.5808 bacteria per square millimeter, and dish B came out to be 16.2975 bacteria per square millimeter. The one with the greater population density is the one with the higher number, meaning dish A. You do have to state dish A. You cannot just simply circle it or box in anywhere like with the population density. You have to state it off to the side somewhere else. Flip it over. We got a couple questions about cross sections and revolutions. Number 3, 4, 5, and 6 come from the Common Core exam, so be prepared. You could see something similar to it when you take it yourself. It says Leo is drawing pictures of cross sections of the right circular cone below, which cannot be a cross section of a cone. Remember that we can cut this cone in 3 different ways. The first way being parallel to the base. So if I cut parallel to the base, I get a circle. Choice 4 is gone. If I cut diagonally or angled, I'm going to try to sketch this here. It's not going to be perfect, but you can see that we have a half oval looking shape, or in other words, a truncated ellipse. So it's not choice 3, because remember we're looking for the one that cannot be true. If I were to cut vertically, that means I would have something like this. You can see the triangle that's formed here if I were to cut vertically. So that's choice 2 gone, leaving us with a square. We can never have a cross section of a cone that's a square. Question 4 says if the rectangle below is continuously rotated around side W, what solid figure is formed? So I'm going to move my paper over so I can kind of sketch this for you. If I were to rotate this edge of my rectangle around side W, this edge would get pulled, dragged way over here and then back around the back side. The top would get pulled way over here, back around the back side. And you can see that this is forming a cylinder, taking that edge going around and around and around, giving us choice 4 as our answer. That one's kind of like the revolving door example that we saw at the beginning. The next one says which object is formed when right triangle RST is rotated around leg RS. So here's the axis in which we're rotating around. This bottom leg will be rotated continuously around the back side and then back around the front. And this edge, this hypotenuse here, will be rotated around the back and it will come out front and keep rotating around and around and around until you see that cone shape. So we have a right triangle is not our answer, sorry. The shape that's formed is a cone. The next one says which figure can have the same cross-section as a sphere? Remember that regardless of the way that we cut a sphere, the cross-section must be a circle. So if you try to get a cross-section of a circle out of any of these shapes, it must have a circular base. So that means choice 2. After this, you're moving on to practice and then an assessment. So if you need to rewind the video at any point in time, remember that you can do that, pause it, ask your teacher for any questions that you're struggling with. Make yourself successful before you take that assessment. Good luck.